uh, in section 1.5, question exercise number 8. The value V of a particular automobile in dollars, so V is in dollars, depends on the number of miles driven, M, and so they make a function H of M, which represents the value after so many miles. Now, so let's now go to the questions. A. Suppose H of 40,000. So that means the value of this vehicle at 400,000 miles of driving, the 400,000 miles, is $15,500. And if the vehicle had gone 55,000 miles, its value would be $13,200. What was the average rate of change over that interval from that many miles to that many miles? And what are the units of this? So the average value would be the value at the end, which was 13,200, minus the value at the beginning, 15,500, over the end miles, minus the beginning miles, which works out to be, so that's just average value. That's straightforward. That's not any thing fancy there. So the difference there, see, 13 to 15 is 2,300, and it's going down, so it's negative 2,300, negative 2,300 divided by, and that went up 15,000 miles. So negative 0.153333. And what are the units? And so this is change in the value over the change in the miles. So this is the values in dollars per mile. So B says, make a sentence that describes what, in addition to the in addition to the information, say it okay, so now we're going to do something more here. All right, thought it was said write a sentence on this one. No. In addition to the information we have already, what if we know the value at 70,000 miles is $11,100. Determine the best possible, and since in that case we don't want to do the slope between here and here, we don't want to do the slope from here to here. 55,000 miles is halfway between 40,000 and 70,000. So we would use the central difference, which says to take the value, find the slope between 2 points, one before where we're looking at, 55,000, and one after. And so the one after is $11,100 minus the one before 55,000, which is 40,000, and that value is $15,500 divided by the difference, 2/8, the difference between the ending 70,000 and the 40,000, or 2 15,000, which is 30,000. And that works out to be, so that's 4,400 divided by 30,000. It comes out to be, oh, and that's going down. That was negative, so it's negative 1.466. Negative 0.1466 dollars per mile. So the slope between these first two places, 40,000 and 55,000 miles of driving, the value was decreasing on average of 15 cents per mile, $0.15 per mile. And then, but right at 55,000 miles, this better approximation for what it's doing right around 55,000 miles is that it's going down only 14 2/3 cents per mile, $0.1466 per mile. And write a sentence to explain the meaning of the result in your answers. I just stated those, so you can go back and listen to them. Okay? And then D. Write a sentence to describe the long-term behavior of the function v. And that goes on. It says, plus another sentence to describe the long-term behavior of H and M in practical terms. So I'm going to go here and say, think about this a little bit. The first one, it's showing that the value of the car, as we increase the number of miles, keeps dropping down, and it gets closer and closer to zero, or actually probably closer and closer to the scrap value of the metal in other materials in the car. So this is basically the shape, and it drops more quickly in the beginning and less quickly towards the end. You can tell that here. It's dropping at a rate of around 55,000 miles, wherever that is on this x-axis. It's dropping at a rate of 15 cents per mile. Later, right there, between here and here, it was going between 40,000 and 55,000. It was dropping at a rate of about 15 cents a mile. Right here, it was dropping at 14 cents per mile. On average, that's what's on average over this larger interview. That's what we did here. The average from before to after it's dropping there. So the amount it drops per mile is decreasing. So the slope is getting less and less steep. It's getting actually more and more increasing in value because it's becoming less and less negative, which is what the second part is. What's the slope function, the derivative of this, look like? Well, we have a fairly negative slope here that tends to get less and less negative as we go on. So we have a fairly negative slope that tends to get less and less negative as we go on, approaching zero. So, but all of these are increasing values. This slope is negative, bigger in absolute value. It's like a negative 2 to negative 1 to negative 1.5 to negative 1.4 to 1.3 to negative 1.2 to negative 1.1. So they're increasing all the time. So the slope is bigger here than it is here. It's bigger in the when you think about negative numbers, but it looks like it's less negative and more towards the positive, which is what this is. So we were supposed to say, in terms of what this car is, that's saying that the car loses value the more miles you put on, but not as fast as you put on higher and higher miles. There's not as much money per mile as it did earlier. The car loses value quite a bit at the beginning and then loses less later. It loses at a higher rate in the beginning and loses at a lesser rate later on. That's the one for the derivative. Okay? All right, that is number 8.